All right, in the Zai book, you read about the bijection rule, which basically says that if you have two finite sets and they have the same cardinality, then they have a bijection. There's a bijection from A to B. And if you have a bijection from A to B, where A and B are finite sets, then they have the same cardinality. All right, so let's look at an example of this. All right, a great example of the bijection rule, or a great example of what the bijection rule is actually trying to tell you, is this question. How do you know you have the same number of fingers on each hand? All right, so the hard way. Let's first look at the hard way. This is how most people answer the question. Most people would say, well, let's see. If I look at my left hand and I count, right? If I look at my left hand and I count the number of fingers on my left hand, right? So over here, I'm looking at my left hand and I say, okay, and I start with my left thumb. That's 1. 2 is the pointer. 3, left middle. 4, left ring. 5, left pinky. Okay, so there's 5 fingers. Okay, you look at your right hand and you say, okay, well, let's see, how many fingers do I have there? Okay, let's see, I start with my right thumb and then pointer, middle, ring, and oh, look, I have 5 fingers. 5 equals 5. So they must have the same amount on each hand. All right, well, that's the hard way. That's working way too hard. And I'm not even kidding around or joking around here. I'm being totally serious. That is working way too hard. All right, let's look at an easier way. Okay. Now, an easier way. Oops, let me see here. Well, let's see. An easier way to do it is to recognize that, let's see, that this here, you can rewrite this with fingers on the left, the count on the right. You have 1, 2, 3, 4, 5. You have thumb, pointer, etc. And then realize, oh, okay, I can just put these two tables together, right? Now think about this, right? This information that I have here, when I just reversed the order, right? I put the count on the right and the number of the fingers on the left. Right, that's all I did. Right, that's all I did right here. That's all I did right there. Right, as I just switched the order. It still has the same information, right? I mean, it doesn't change. It doesn't change anything. It still holds exactly the same information. And you say, oh, okay, well, the count is together, so you can put them together, and then you see that, oh, look, down here at the easier way, right? An easier way. What I have right here, right? That, oh, we could just put those two count columns together and look, right? The fingers on the left, there's 5 of those, there's 5 of those, right? But the easiest way is to just get rid of the count altogether. There's no reason to count at all. And that's the point. All right. That's really the point of the bijection rule. Now, and let's think for a second. Do we really have a bijection here? Okay. So remember from the previous video, right? It's a function. The thing on the left right? If the left-hand column has all different entries, and it sure does have all different entries. Let's see, it's onto because there's no D and E's. Okay, it's onto, there's no D and E's, and the right-hand side here is all different, so therefore it is, in fact, a bijection. And you can see here without even counting, right? You don't even have to think about the fact that there's 1, 2, 3, 4, 5 columns, or 5 rows. You don't have to even count the number of rows to know that there's the same amount. All you need is the fact that there's a bijection. Bijections, if you have a bijection between two sets, you know that they both have the same amount. And now you might let me just kind of give you a little illustration. Now you might take your hands and look at your hands there. Look at your hands there. Okay, now this is a really good illustration, and I apologize if for anyone who doesn't have all of their fingers, and I'm not saying that to be funny or anything like that. I did have a student a few semesters ago who I used this example in class, and he didn't have all of his fingers. So, but he was he liked the analogy or the lesson. So I hope you will too. Please don't take offense. All right, so you look at your hands now, right? And you see on your left you got your fingers there, and then on your right you got your fingers there. You can do exactly what this is saying here in the easiest way. Now just put your pinkies together. Put your pinkies together there. Now put your ring fingers together. Now put your middle fingers together. Now put your pointer fingers together, and now put your pinky together. Now you have a bijection. You're staring at a bijection in your hands. Right, let me draw this thing. Okay, let's see. You got your pinky, ring, middle, pointer, thumb, and then you got your pinky, ring, thumb, right like that. You see how you can put them together? That's a bijection, right? The fact that you can put them together like that and make a bijection, that is why you have the same number of fingers on each hand, not because they both add, because if you count them, you get 5. And that's the bijection rule.